Solving systems by elimination. Our objective is to solve systems of linear equations in two variables by elimination, as well as compare and choose an appropriate method for solving system of linear equations. Why learn this? You can solve a system of linear equations to determine how many flowers of each type you can buy to make a bouquet. Let's start by looking at the steps involved in solving systems of equations by elimination. Step 1. Write the system so that the like terms are aligned. Kind of like this. So 2x plus 3y equals 8 and 4x minus 3y equals 9. Notice how they're all lined up. Eliminate one of the variables and solve for the other variable. So this is when you're going to either add or subtract vertically. So the only one that we can get rid of right now without having to multiply to make them the same would be the 3y and negative 3y. So if we were to add these together, they would go away, leaving you with 6x equals 17. So you want to solve for the variable, so we would solve for x, and then the rest of this is very similar to substitution. Substitute that value back in to one of your original and solve for the other variable. When you're done, write it as an ordered pair. This part, however, is the different part than what we were doing in the past. So let's practice. Alright, so we have x minus 2y equals negative 19, and 5x plus 2y equals 1. What are the set of variables that we can eliminate? Well, if we add, we can eliminate our y's. So if we add, that leaves us with 6x, no y's at all, equals negative 18. Let's solve for x, so therefore x must equal negative 3. And now we begin the part that we're used to doing. So we're going to take our x equals negative 3, and we're going to substitute that back in. So we've got negative 3 minus 2y equals negative 19. And we want to solve for y. So we would add 3 to both sides. So we'd have negative 2y equals negative 16. And divide by negative 2, which leaves you with y equals 8. Well, we have our x and our y, which is enough to make our coordinate. So negative 3, 8. Try this next one on your own. When you return to the video, the answer will be revealed. So to eliminate, we're going to add our two equations together, leaving you with 3y equals 12. Solve for y. Y equals 4. Now we're going to substitute that 4 back into one of the original equations so that way we can get the answer or the value for the other variable. Solve for x, and you have an x, y coordinate, so negative 2, 4. Let's try doing elimination using subtraction. So if we look at this example, notice how you have a positive 4y and a positive 4y. if you were to add these two equations together, you would now have 8y. You want to eliminate, not make bigger. So we're going to subtract. So 3x minus negative 2x leaves you with a positive 5x. You have no y's. And then we have 18 minus 8, which leaves 10. So x must be 2. Alright, now we need to substitute our x value back into one of our original equations and solve for the other variable. So we have 3 times 2 plus 4y equals 18. Subtract 6 from both sides. So we have 4y equals 12. Divide by 4, so y equals 3. We have our x and our y, so write it as a coordinate, 2, 3. Try this next one on your own. When you return to the video, the answer will be revealed. So we will subtract both of our equations, leaving you with x equals 4. Substitute your x value back in, solve for y. And then you're left with your xy coordinate of 4, 1. Let's get a little trickier. Notice how, in this example, you can't simply eliminate the x's or the y's by simply adding or subtracting, because none of the coefficients are the same. To change this, you can multiply an entire equation by a single value. So, if we multiply our second equation by 2, it will cause our coefficients of at least one of our variables to match up. So we have 2x plus y equals 3 for our first equation. And then in our next one, we're going to have negative 2x plus 6y equals negative 24. As a recap, all we did was multiply each term in our equation by 2. And now we can add or subtract. In this case, we would add because they're opposites. So that leaves us with 7y equals negative 21. So y must equal negative 3. Take your y value and substitute it back in. So we have 2x plus negative 3 equals 3. Add 3 to both sides, so we have 2x equals 6, so therefore x must equal 3. Last step, to write it as a coordinate, so we have 3, negative 3. This one is a little bit more involved than the previous one. Notice how you can't simply multiply only one of the equations by a single value to be able to have a set of coefficients that you can cancel out. Sometimes you have to multiply one value to the top equation and one value to the second equation. So in this case, if we multiply the top by 2 and the second by negative 3, we will have values that we can cancel out. So let's distribute our 2 all the way across. That leaves us with 14x minus 24y equals negative 44. And then let's distribute our negative 3. We have negative 15x plus 24y equals 42. Now we have a set of coefficients that we can eliminate or cancel out. So to do this, let's add. That leaves us with a negative x equals negative 2. So x equals 2. Substitute that value back into one of your original equations. So we have 7 times 2 minus 12y equals negative 22. So negative 12y equals negative 36. So y must equal 3. Last step, write it as a coordinate. And there you have it. We've learned 3 different ways of solving systems of linear equations. This is a summary of each of the 3 methods: graphing, substitution, and elimination. Use graphing when both equations are solved for y, or if you just want an estimate of a solution. Substitution. A variable in either equation has a coefficient of 1 or negative 1. This makes it easier to solve or faster to solve. Both equations are solved for the same variable, as then you can just simply set them equal to each other, or if either equation is solved for a single variable, because then you can take whatever that value of the variable is and just substitute it into the other one. Elimination is good when both equations have the same variable with the same or opposite coefficients, because then you can simply add or subtract to eliminate. The other time when to use elimination is when a variable term in one equation is a multiple of the corresponding variable terms in another equation. So kind of like what we were doing today. And that ends our video lesson on solving systems by elimination.